Hey Trick Class, we're going to look at this problem from 10.2 homework set where we are transforming a polar equation into a rectangular equation. And the big things that we have to see on these types of problems are the identities that are going to help us are going to be x squared plus y squared is r squared. It's going to be x equals r cosine theta on this one, and then also y equals r sine theta on some other ones, just depending on different variations of these problems that you get. So when I look at this, I see cosine theta, but I don't see r cosine theta. So multiplying this whole entire right-hand side by r will create an r cosine theta that I'll be able to transform into x. And again, that's what I'm doing. I'm trying to get it into rectangular coordinates. So I need x's instead of r's and thetas. So r cosine theta is x, so that would create that on that side. And then whatever I do to the right side, I have to also do to the left, and that will create r times r, which is r squared, which I can also replace with x's and y's. So that's the path here. All right, notice squaring both sides is not going to help, because by square both sides I would have r squared, which is x squared plus y squared, but I'd have a 4 cosine squared theta, and I don't have a direct path to x or y from that. I need an r times that cosine of theta. So that's the reason why we're going to use that. All right, again, so multiplying both sides by r, I get r squared equals negative 2 r cosine theta. R squared is x squared plus y squared. And that equals negative 2. R cosine theta is x, so negative 2x. Alright, now that I have an x squared and an x together, I'm going to add that negative 2x over and get x squared plus 2x. Alright, I'm going to leave a space plus y squared equals, there's nothing left over there, so I'm just going to type equals 0. When I add the 2x over, there's nothing left on the right side. And then we're going to do something called completing the square. So x squared plus an x is almost a perfect square binomial. And what we need is a constant that is the square. The constant needs to be the square of half of this x coefficient. So if I divide that 2 that's in front of x by 2, I get 1. And then if I square that 1, I get the number I need here. So I add 1. That's a positive 1. So I add 1 here. That means I'm going to add 1 here. All right, and then what you get when you factor this would be x plus this number, the number before you squared it. It's the same here, but it's not always the same. So x plus 1 squared and then plus y squared equals 1. So what we have here is a circle of radius 1, and the center is negative 1, 0. All right, these are the things that would make the squared pieces 0. So negative 1 for x, negative 1 plus 1 is 0. 0 squared. And then obviously y, there is nothing being added or subtracted, so 0 would make that 0. So we're looking for the things to get the center. What would make these parts that are being squared equal to 0? So it's negative 1, 0. That's the center of the circle. And the radius is 1, but not just because of that, not because of the equals 1. It's because the square root of 1 is 1. It's, again, x squared plus y squared is r squared. Squared radius is 1, so the radius is also 1. So there's our center, our equation, and our center is negative 1, 0. All right, so there is our rectangular equation, and then the next part is going to ask, what is this? And it's a circle with the center at negative 1, 0, not 1, 0. So everybody looks at that and they see a positive 1, so they want to grab that. But again, it's the center is what makes the squared pieces equal 0. So there is our correct choice of what we're looking at. All right, and then the graph, you're just looking at the one that has a circle, so A and D are out. Centered at negative 1, 0, so C is out. That's at positive 1, 0. So B is our answer. All right, now again, we can always graph this. This is r equals negative 2 cosine theta. So I'm in, again, polar mode. If I press y equals, it's now r equals. I'll clear that equation out. Negative 2, don't do minus 2. Negative 2 cosine. All right, there's that. I'm going to hit graph. All right, that doesn't quite look circular. The reason is because I'm not in a square window, so I'm going to choose option 5 for zoom square, and now that thing looks circular. You could zoom in on this a little bit. You would just need to make sure your values, your ratio of x to y, like this 12.13 roughly to 8 ratio kind of stays in. If I did zoom in from a square window, it should remain square. So there is a better, like a tighter version of that. Each tick mark here is 1 unit. You can see that in the window. The X scale is 1, the Y scale is 1. So when I'm looking at that, I can count. That's 1 unit over left, that's the center. I'm going up by 1, I'm going down by 1, I'm going back to the right 1 because I'm hitting the origin, so that radius is 1. I could also get it from the graph.